Hello students, today we are going to start the next chapter. Hope you all have completed the previous exercise of ratio and proportion. We are going to start with the chapter arithmetic progression. Now before I start the topic, let us understand in brief what arithmetic progression or geometric progression actually deals with. See, if I consider a list of numbers, for example, two examples I have taken. 3, 5, 7, 9, 11 and so on. The other is 1, 1 by 2. The other is 1, 1 by 2. 1 by 3, 1 by 4, 1, 1 by 5 and so on. Then in that case, here each number in this list of the numbers which is given is a term, right? Which means that 3, 5, 7, 9, 11, each one of these, we can say it is the first term is 3, second term is 5, third term is 7 and so on and so on. Similarly, the second one, if I see, what is it? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 and so on. So what is it exactly? It is that each one of these is a term itself. Okay, this is the first term 1, second term is 1 by 2, third term is 1 by 3 and so on. We have n infinite terms. Okay, now here each number, as I said, is in the list is called a term. In the first one, if I see very carefully, each of the term, the next succeeding term is 2 more. 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 2, 11. And that is how the series is proceeding. So each succeeding term in this first is obtained by adding 2 to the previous term. If I talk about the second one, what is it? We all know 1, 2, 3, 4, 5 and so on. These are all the natural numbers. If I take the reciprocal of the next natural number, I get the term of the series. 1 is the first natural number, 1 by 1, that is 1. Next 2 is the natural number, so 1 by 2, like that, so on. The series is formed. Now this pattern, if I understand, then there are two types of patterns which we can talk in maths. One, where there is a common difference. Okay, for example, the first one which I have taken, the difference between any two consecutive terms, if I take, is always 2. 9 minus 7 consecutive terms, 2 the difference. 7 minus 5, the difference is 2. 11 minus 9, the difference is 2. So such type of list of numbers is the arithmetic progression, or AP we term it as. So in this particular chapter, similarly GP also, geometric progression, we are going to understand. It's a different kind of progression. We are going to understand it in the further exercises that we'll be doing. But for now, let's understand properly what's in APs. Arithmetic sequence, what is it? Arithmetic progression or arithmetic sequence, AP, what is it? It is a sequence that has a common difference. Okay, and if I am supposed to find the formula, that what will be the nth term, say particularly the 5th term, 4th term, 70th term, 13th term, then in that case, that nth term can be obtained using the formula an is equal to a, that is the first term, plus bracket 1, n minus 1. N is what? The number of terms. 17 term, 40 term, third term, 5th term, like that. Minus 1 into d. What is d? The common difference, as we discussed. So I've written it here also. An is the nth term of the sequence, a is the first term of the sequence, and d is the common difference. Okay, so this must be written in your registers before you start this chapter 9, exercise 9.1. This should be written as it is. Okay, you all can copy it in your registers as it is. Let's understand it more. So let's repeat once again. Arithmetic sequence, what is it? It is a sequence of given values which is a common difference, okay, between any two consecutive numbers. If I take any two consecutive, see, it will be more clear with this notation also. The second point which I have written is the notation of terms in an arithmetic sequences. If the sequence is say a plus d, what are we doing? Every time the common difference d is added. First term a was there, so a plus d. The next Again d is added, so a plus 2d. Again d is added to it, so a plus 3d, and so on. That is how we are getting the next successive term of this particular sequence. Where a is the first term, d is the common difference. Now let's check, as we were saying in the very first point, that the common difference between any two consecutive. Find out a plus 3d and minus a minus 2d. Of course, I get the d, that is the common difference. Okay, that's what we were talking. Now, nth term, just now I've told you, nth term or general term of an arithmetic progression or arithmetic sequence is a plus n minus 1 into t. Again, repeating, a is the first term, n is that particular nth term, fifth term, fourth term, whatever it is. D, it is the common difference between the two consecutive terms. Let's understand the fourth formula, what it is. It is the sum of first n terms. If I say find the sum of first 5 terms of this AP, then the formula for the first n terms sum in an arithmetic sequence or progression is n by 2, bracket open, 2a plus n minus 1 into t. Okay, this again is to be written in your registers as it is in the form of formulas or notes, so that the first two exercises 9.1 and 2 are not at all a difficulty as far as the formulas are concerned. Let's proceed with the exercise now. Once again, recapitulate the formulas to find the nth term, where a is the first term, d is the common difference. It will be an is equal to a plus n minus 1 into d. Sum of the n terms, n by 2, bracket open, 2a plus n minus 1 into d. Okay, let's start the exercise now. In the very first exercise, the first question, we are taking 2 parts as classwork. Okay, the remaining all are homework. So this is the series, this is the sequence, this is the progression given, and we have to find out. Yes, please. We have to find out firstly what's the first term. We all can see it in the very first term. What's the common difference? Subtract 2 consecutive, 5 by 3 minus 1 by 3. It's 5 by 3 minus 1 by 3. It is 4 by 3. Let's take the next. 9 by 3 minus 5 by 3. Again 4 by 3. What's the common difference? 4 by 3. What's the first term? 1 by 3. By looking at the given sequence, we can see the first term, and to find out the common difference, we take the difference of 2 consecutive terms. Okay, the second term minus the first term, third term minus the second term, like that. Take the next sum. What's the first term? Of course, it is minus 3.2. Okay, the first one, minus 3.2. What's the common difference? Minus 3 plus, why plus? Because minus we have to do. So, minus 3 minus 3.2, which is minus 3 plus minus plus 3.2. What do I get? 0.2 plus. So, the common difference is 0.2, and what's the first term? Minus 3.2. Okay, so first question, remaining parts homework must be done. Let's move to the next question. Now a and d are given. In the next question, value of the first term, the common difference we are given, and we have to write the APCs. Be very clear, we are not supposed to, we are not being told to till what value we are, till what particular term we have to write. So we'll be writing a few, we'll be writing, and then we can just write dot dot dot, that means so on and so forth, the sequence proceeds. Okay, so first few, at least 4-5 terms you will find out. Okay, because first one is already given, so 4 to 5 terms. Okay, so a is 4, d is minus 3. What will you do? Every time add, firstly write the first term as it is, then 4 and minus 3, a plus d, that is 1. Next, a plus 2d, 2 into minus 3 is minus 6, 4 minus 6 minus 2. Next, a plus 3d, 3 3s are 9, minus 9 plus 4, that is minus 5, and that is how the AP is formed. Clear, everyone? Let's take now one more example where we are given the fraction values. Again, it is not a problem at all. Okay, let's proceed. It is a is equal to 1 by 2. A is equal to 1 by 2. Common difference d is minus 1 by 6. So again, we can do it by, yes, first term as it is. For the second term, sum of the two. Okay, so that is what it is. We get it as 2 by 6. Next, again, we will add first term with this common difference, and again we are getting the next. So like that, the AP series will be formed. Okay, this part is clear, everyone, right? So this is what it is. Okay, we are given the first term, we are given the common difference, a plus d. Next term, how will we get? A plus 2d. So that is a plus 2d, 2 minus 2 by 6. Minus 2 by 6 means, yes, minus 2 by 6. This is it is, and plus 1 by 2. 1 by 2, we are having 1 by 2 and minus 2 by 6, because a plus 2d is a formula. So what do I get? 6 as it is the LCM. 2 3s are, so 3 minus 2, that is 1 by 6. Hope you all have understood this particular part. Yes. So that is what it is. And the next term, d plus 3d. If I do 3 multiplication, what do I get? 1 by 2 minus 3 by 6. 3 by 6 is what? 1 by 2. 1 by 2 minus 1 by 2 is 0. So that's what the next term is. Okay. So that is how we can form the particular AP. Let's move to the next question. So here we are given the series. Okay. And then what we have to do is, in this third question, which of the following list of the numbers form an AP? We have to check whether the given sequence forms an AP or not, because there are few which will not form. What is the first thing that we need? We need to have a common difference. If the common difference is same for the given terms, we do not have to go for n number, because that is not given, not definite. Okay. See, we are having two types of AP. Finite, when the number of terms, we know that these many terms are there in the given AP. An arithmetic progression is called a finite AP only if it contains finite number of terms. Say 6 terms, 7 terms, 100 terms, 200 terms. That is particularly it is defined. But if it is that an arithmetic progression which is not having finite number of terms, infinite terms is dot 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 and so on, we don't know, so then it is called infinite AP. So for an infinite AP, what will you do? Only the given terms that are there with us, we will take out their common difference, and if that common difference is the same, we will say yes, it is an AP. And once that is an AP, what we have to do? We have to write the next three terms. The question says find the common difference. Of course, we will be getting by subtracting the two consecutive, and then write the next three terms. So I'm taking one particular example of the same. Let's see this. If I'm given the series A, 2A, 3A, 4A, so what's the first term? A, yes. What's the common difference? Let's find out. 2A minus A, it is A. Next, 3A minus 2A, A. 4A minus 3A, again it's A. So the common difference I can see 1, 2 and 3. Everywhere it's same. The common difference is same. So it's an AP. Now what are they asking? What's the common difference? Yes, it is 8 itself. Next three terms. Next three terms will be what? First term, second term, third term, fourth term, fifth term. What will we do for that? Yes, 4A, that is the fourth term, plus the common difference. So 4A plus A, that is 5A. 5A plus A, 6A, and next 7A. Like that we can work it out. Okay. Clear everyone? Now the next one more sum I am taking, where we are given A, 2A plus 1, 3A plus 2, 4A plus 3, and then again I have to check whether this forms an AP or not, and if that is an AP, again I have to go for the next, that is, I have to find out the next three terms. Okay. So 2A plus 1 minus A, what do I get? A plus 1, that's the common difference. Clear? 3A plus 2 minus 2A minus 1, what do I get? Again A plus 1. So what I can observe again, A plus 1, A plus 1, A plus 1, the common difference is same. So that is the value of the D, common difference. It forms an AP? Yes, it forms an AP. Next three terms, how do I get? Take the last term, add to it what? Add to it the common difference, that is A plus 1. A plus 1 means 5A plus 4. Again 5A plus 4, add A plus 1, 6A plus 5. That means each of this is increased by 1. 5A becomes 6A, 4 becomes 5. 6A becomes 7A, 5 becomes 6. Like that the series will be continued, the sequence will be continued. So this was all about exercise 9.1 students. Okay. So you are supposed to complete the remaining parts of the exercise as a homework. Fine. We'll continue with exercise 9.2 in the next class. So all of you must be prepared for the same. Okay.